All right, welcome to Math 2 Notes, Lesson 1-4, Rewriting Exponential Expressions. All right, so today the goals of our lesson, our learning targets, are to rewrite powers that have variable exponents and use properties of exponents to transform expressions for exponential functions. All right, so I just want to remind you we have a bunch of different rules. You should have your handout in front of you for those power rules. Let's go ahead and begin. So it says an exponential function contains a variable in the exponent. So for example, an exponential function would be something like 3 to the x power or 5 to the x power. That's an exponential function. And so what happens is, as we change the value of x, like for example, if x was 1, this would just be 3 to the first, which is 3. Or if x was 2, we'd have 3 to the second, which is 9, and so on. So those are exponential functions. Okay, look for and make use of structure. Each expression contains a variable term in an exponent. So the variable term is in the exponent. Use the power of a power property to rewrite each expression so that the variable exponent does not have a coefficient. The first one has been done for you. So first there's some properties that they want us to look at, which is the power of a power property. So the power of a power property is a to the m to the n power is equal to a m times n. So this is the power of a power property. We're going to be using that property. We're going to be using that property to rewrite so it does not have a coefficient. So just to remind you, whoops, this should be an n right here, I apologize. Just to remind you, a coefficient is like, for example, if you have 2x, that is your coefficient, right? The value in front of the variable. The first one has been done for you. So let's take a look at what they did. They said 8 to the 2t is equal to 8 to the 2 times t. That's this rule where we're multiplying. And then that could be 8 squared to the t power, right? Which is 8 squared to the t power, which 8 squared is 64. So let's go ahead and try this one. So we're going to rewrite this. This is negative 2a to the 5 times x. And then here we have two values. We have two items, factors, I should say, two factors inside the parentheses, whereas here we only had one. That means each of these is being raised to the 5th power. So we're going to rewrite this as negative 2 to the 5 and then x to the 5. And then we're going to, I'm sorry, that was a to the 5. I apologize, a to the 5. And then we're going to leave our exponent of x on the outside. So negative 2 to the 5th power is negative 32. You can check that, right? Negative 2 to the 5th is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And then a to the 5th power. And then we have that x on the outside, so we'll leave that as an x. All right, next one. Let's take a look. So this is 1/16 to the 3y over 4 power. So we're going to rewrite that as 1/16 to the, now this is a fraction issue for a lot of you. Y is in the numerator, so it's going to stay in the numerator, but to separate this out, right, we're going to just rewrite the coefficient, which is 3 over 4. If I were to multiply this back, I still have 3y over 4 because y is in the numerator. Okay, and then we could rewrite that as 1/16 to the 3/4 power, and then to the y power. Now we don't know what 3/4 power means yet for 1/16, so we can't do anything further with that. And then finally, well, I guess we could, if we wanted to, we could put 1 to the 3/4 power over 16 to the 3/4 power, and then all to the y power. Those are equivalent, but either of these is acceptable. And then the last one, I know I'm going to need some more room, so I'm actually going to come over here off to the side to do this one. So we have 4b squared c to the 3z power. So I'll rewrite that as 4b squared c to the 3 times z. And then this is similar to the first one where we need to apply this 3 to each of these exponents. This is going to be 4 to the 3 power, b to the, remember we're multiplying this together, so that would be b to the 6th power, and then c to the 3rd power, and then all to the z power. All right, let's go ahead and look at number 2. It says each expression contains a variable exponent. Use the power of a power property to rewrite each expression so that the variable exponent contains a coefficient. The first one is done for you. So here it said the variable exponent does not have a coefficient, and here they want us to do the opposite. They want us to make sure that the variable exponent does have a coefficient. So the first one, they have 125 to the s power. And they rewrote 125 as 5 cubed, and that's because 5 times 5 times 5 is 125. And so that's 5 to the 3rd power, all to the s power, and then we can rewrite it as 5 to the 3s power. Okay, there's a couple different ways to do the second one, so I'm actually going to take out a separate sheet of paper. I encourage you to do the same thing. Right, let's make a note that we're on page 14. So this is page 14. Page 14, and we are on number 2. Okay, and this is the second one. It's 8 times 27. I believe that is to the, yes, r power. Now, again, our goal is to rewrite this with a exponent, a coefficient on the exponent. So there's a couple ways we could do that. You could write this as, I'm going to multiply 8 times 27. So 8 times 27 is 216. So it's 216 to the r power. Oh, and then we could figure out what number is 216, right? What could we rewrite 216 as? It's a large number. So let's see, if I divide 216 by 2, I don't think that would quite help me. So 216 divided by 2, divided by 2 again, divided by 2 again, and I can see now I get an odd number. So definitely 2 cannot be my base, right? My base cannot be a 2. I could try dividing 216 by 3, another prime number. So 216 divided by 3, and now I divided by 3 again, divided by 3 again, and now it's not divisible by 3, so it cannot be that 2 or 3 is my base. But what I do notice is that both 2 and 3 went into 216. So I'm going to check 6, because 2 times 3 is 6. So 216 divided by 6 is 36. Divided by 6 again, whoops, divided by not 3, 6 is 6. Divided by 6, I get to a 1. So I had to divide 216 by 6 1, 2, 3 times. That means if I take 6 and I raise it to the 3rd power, I should get 216, and I do. So I'm going to rewrite this as 6 to the 3rd power, all to the r, and then I can use that power property to write this as 6 to the 3r power. All right, the other way to do this problem would have been to rewrite 8. 8 is 2 to the third power. And to rewrite 27, 27 is 3 to the third power. And that's because 2 times 2 times 2 equals 8, and 3 times 3 times 3 equals 27. And now, since they both have a power of 3, I could rewrite this as 2 times 3 to the third power, and then to the r power, and then that would be 2 times 3 is 6 to the third, and then to the r power, which is 6 to the 3r power. Now, something that I want to encourage you to do during the notes, at any time, if you don't understand something that I've done, you need to pause it and rewatch that segment again. So if right now you're a little confused, you need to stop, pause it, and rewatch this segment again. And then if you're still confused, make yourself a note on your notes. Make a star, whatever you need to do, and say, ask Miss Sedlak in class tomorrow. Okay? All right. And I'll remind you of that at points throughout the notes. So this would be 6 to the 3r power. Let's try that again. We have another one right here. This is number 2 as well, but it's the next part. So we're going to rewrite it. I'm going to do it on my separate sheet of paper. We have 16a to the 4th over 81 all to the x power. So 16a to the 4th over 81 all to the x power. All right, so I am going to implement option number 2 here. I cannot figure out what 16 over 81 would be as one number, but what I can do is look for something that maybe they all have a 4th power in common. This is keying me that it's probably a 4th power. So 16, if we use the structure of the previous one, 2 to the 3rd power was 8. Well, 2 to the 4th power is 16. And you can check that. 2 to the 4th power is 16. So I'm going to rewrite 16 as 2 to the 4th, and then that's a to the 4th over. Now I know 27 was 3 to the 3rd power, so 81, I believe, is 3 to the 4th power. Let's check it, and it's true. 81 is 3 to the 4th power. So I'm going to rewrite 81 as 3 to the 4th power. And remember, this is all being raised to the x power. Now, since they all have the same power, I can rewrite this as 2a over 3 all to the 4th power. That is the power rule. That's the rule for multiplying through, right? The power rule says, or sorry, the rule is that you multiply each of these exponents by that 4, the power rule. And then I can rewrite this as 2a over 3 to the 4x power. All right, so that would be 2a to the 3, or sorry, 2a over 3 to the 4x power. All right, it says, how are the steps you followed in items 1 and 2 alike? How are they different? So what I noticed is that in item 1 and 2, I was working one direction in item 1 and working backward in item 2. So in item 1, I'm going to make this a little better there. Okay. In item 1, I was bringing that 5 into whatever I had, right? And then using that to simplify. And here I was undistributing that power, like the 4th power, right? So it's like you're working in reverse. And so in your own words, if you would please fill in what you felt about item 3. So pause right here and go ahead and fill in how you reasoned about what you did that was different and what you did that was the same. All right, we're going to scoot down to example A. It says an investment earns an annual interest rate of 4.6%. Find the monthly interest rate. All right, so let me rewrite this for you. 4.6%. So this is, I'm actually going to stay on the same page, the same paper. I'm just going to slide it underneath because we're still on page 14. Now this is example A. So example A, it says that the annual interest rate is 4.6%. So 4.6%, to change this back to a decimal, you move the decimal place 2 times and put your placeholder of a 0 and drop your percent. So this is 0.046. Always we move our decimal 2 times and drop the percentage. All right, now an annual interest rate. So an interest rate means that whatever you invest, you get 100% of your money plus 4.6%. That is how interest works. You get 100% of your money back plus 4.6% of your money. So this is going to be 104.6%, which, if we change this back into a decimal, will give us, we move the decimal place 2 times, 1.046. And that is my base. That is where this 1.046 came from. And that is where this 1.046 came from. Okay, so it says write an exponential expression for t years. So that means after t years, I would get 1.046 to the t power. Each year, it's exponentially growing. You're taking whatever you started with and you're compounding it each year. So t represents the years. Then it says think. T years equals 12t months. So use the power of a power property to write an equivalent expression with the exponent 12t and simplify. So what they want us to do is they want us to rewrite this 1.046 with this expression, or this exponent. And that's because this is a monthly interest rate. Annually, there's 12 months per year, so 12t. So we want to know how much we would make per month. For this statement to be equivalent to this statement, I would need to multiply by 1 over 12 to 12. Again, for t to equal 12t, I would need to multiply by something here, which would be 1 over 12. If I multiply 1 over 12 to 12, the 12s cancel, and I would have t equals t. And so that would be this power property right here. And then I would have to use a calculator to do this. This, inside the parentheses, I have 1.046, and it's being raised to you have to use your calculator. This is 1 divided by 12, the 1/12th power, and that equals 1.003, and I'm going to round it to an 8. So this would equal 1.0038 to the 12t power. And if we were rewriting this as a percent, right, this would be 1, we would move our decimal place 2 times back to the right, 100.38%. And that would mean that the interest rate, we're going to subtract off, just like here we had to add 100% to this. This time I'll subtract 100% from it. So 100.38% minus 100% would give me 0.38%. Now let's go back and talk about what we've just found. All right, so what we just found was we took an annual interest rate. This is an application problem. If you invest in a bank account with an annual interest rate of 4.6%, and you want to find the monthly interest rate, this is what you would do. I'll replay those steps here. First, an annual interest rate, of 4.6% means that you're adding 4.6% to your initial investment of 100%, which gives you 104.6%. All right, converting that back to a decimal, that's 1.046. That means each year you get 1.046 each year to your original investment. So if time was 1, you'd have 100%, so you'd have 1.046 of your money. After 2 years, this would be raised to the second power. After 3 years, to the third, and so on. Now, if we want to find the monthly interest rate, we know there are 12 months per year, so 12t. And to keep this variable equal to this variable, I would need to multiply by 1/12 inside, because 1/12 times 12 gives me my original t back. And then on a calculator, that's the only way you can evaluate this. On a calculator, you would raise 1.046 to the 1/12 power, and you get 1.0038. Changing that back to a percentage, here's your percentage, and then to find your actual interest rate per month, you would subtract off the 100% that you had, and you'd have a 0.38% per month interest rate. All right, moving on to example B. All right, example B. A group of students is researching the population growth to use an annual growth rate of and using an annual growth rate of 0.85%. The second group of students wants to study the same population using the growth rate per decade. So this is our annual growth rate. We want to do it in decades. So find the growth rate the second group of students should use. So we're going to flip over to the next page, which is now we're on page 15. So this is page 15, example B. And remember that our growth rate annually was 0.85% annually. And so, again, growth rate means it's growing. We have 100% of our initial population. To that, we're adding 0.85%. So that would give me my growth rate of 100.85%. Changing that value back into a decimal, we would move our decimal place 2 times, and we would get that 100.85% is the same as 1.0085. And that's what they've done here. Now we're raising this to the t power because it's growing exponentially. So there's my exponential growth. All right. Now, how many years is in a decade? So 1 decade is equal to 10 years. So we want this now to be into the 1/t, right? So it takes 1 decade is equal to 10 years. That means that this is 1/10. T is 1/10 of a decade. So I'm going to rewrite this as 1.0085 to the 1/10 t. Again, this is how I know that it's 1/10. And then to keep these two exponents equivalent, t is equal to 1/t. What value would I need to multiply here in order for these two to be equivalent? I would need to multiply by 10/1. My 10s would reduce and I would get t equals t. So that means that 10 must go inside of my parentheses so that when I raise these two to the, when I multiply these two, I get t. Now, on a calculator, the only way you can do this is on a calculator. Well, a base of 10 is not hard. But on your calculator, you're going to verify 1.0085 to the 10th power, which is 1.08826. Oh, sorry, 88326. So we're going to rewrite this as 1.08836 to the 1/10th power, 1/10th t power. Now that means that the new group, right, would need to use this growth rate. This growth rate is, remember that we have to take the 100 as a percent, right? This would be, move the decimal 2 places. So this would be 108.8326 percent minus, we'll take off our 100% growth rate, which would give us, or 100% for the original population, which would give us a growth rate of 8.8326%. And there is our final, right? That is our final percent. All right, you guys are going to do the try these A through B. What I'd like you to do is I'd like you to pause the video here. I'm going to check the time on the video. We're at 25 minutes. This is a good point to pause. So I'm going to pause the video here. You're going to do the try these, and then you're going to look at the next video and see if you got them correct.